have to share my screen.
Yes, you can share.
Is my screen visible?
Yeah, it's visible, Karna ji. We can start now.
Okay. Hi everyone, and today we have come with another session, and this session is similar to what we did in the previous session. Previous session we detected artificial molds, and this session we are going to detect artificial content. So there are a lot of deepfake contents being generated these days. To give you a short example, as you might have used Instagram. Everybody is on Instagram, and you use filters in Instagram to make reels, to make posts. Those filters actually morph your picture on somebody else's picture. That's what we, in a technical term, call it as a deep fake. Deep being because the deep neural networks or deep learning methodology is used behind generating fake content. And as we have seen, the problem statement is very clear with this. You have to come up with an algorithm or a technique which will identify the generated deepfake content available. The content can be video, audio, text. It can be news. It can be blogs. It can be anything. Any content which is fake, which is not real, it has to identify. So, like last time, this time also, we will first understand what deepfake is, how it is generated, and then the problems associated with it, and what solutions can we come up with. Until and unless we do not understand, as I said always, we do not understand the background, the business knowledge, the problem knowledge, we will not come up with good solutions. So we always have to understand this. So we'll start with what actually deepfake is. It's a technique which synthesizes human image. When you synthesize or change a human image based on artificial intelligence. As I said, deep word itself says it derives from deep learning. So when deep learning methods are used to generate or synthesize images, human images, it can be videos, it can be audio. Audio also is morphed these days. So any content which synthesizes or is a technique which synthesizes a human image, a human reference, a human semblance using an artificial intelligence. For example, you can see the picture on the screen. It is overlapping existing image on a video. So you have a video for some celebrity maybe, and you are taking your own video and trying to morph on it or overlapping the existing video with that image. The machine learning technique or the AI technique which is used for this is called as generative adversarial networks, GANs, very popularly used to generate deepfake networks or to create a deepfake network generating any kind of deepfake content. We'll talk about this because unless, my professor used to say it, until and unless you don't know the technique of how it is made, you can never overcome on to reversing it or doing a reverse engineering on it. So when you have to do a reverse engineering, you always have to understand it, how it is being made. We'll talk about deep learning. As I said, it was coined in the year or originated in the year 2017. Very, very, very recent. And it is blending the words deep learning and fake. Everybody here, you might know deep learning. If not, then we'll talk a little bit about deep learning. Deep learning is actually a branch of machine learning that deals with machines. It is basically it's called as deep because it resembles a human brain. It generates a lot of neurons. Inside human brain, you have a lot of neurons. and those neurons pass on the signals and give you directions, or gives you an ability to decide on something. In similar fashion, we generate artificial neural networks. So it's a neuron which acquires resemblance to human brain. So we generate these neurons, network of neurons, again to decide on something. The only thing is it is based on machines. The machines are trained to have an ability on a decision making power for some of the other content. And deep word it has derived because the brain, you can understand how much of a neurons we have in our brain. Similarly, those many neurons we have to actually gather and create a network. It creates a deep network, very deep network. That's what the word is deep learning coined to this machine learning branch. And usually when you will see all the deepfake contents, you will have to use deep learning methods to come up with the solution. Any solution you try to come up with, this deep learning methods only you'll be using. Let me show you some examples, and I just put it up on the screen. Sometimes how deepfake networks are generated. It's a normal video you can see which is being played. For you, it's a very normal video, but actually this video is morphed. The person, the identity which you're seeing is not real. It's not a real person. They have overlapped the images. You can see it's a lady, but the face of a man. There's a face of a man being overlapped on a lady, on a girl, to generate deep contents, deep fake contents. And these days, they are so precisely done that you will never be able to differentiate whether it is real or it is not. Even the lip sync, the lips are being synced to the audio played in the background. So your lip movement, your eye movement with a naked eye, you will never be able to figure it out whether the content whichever is available is a fake or a real. Similarly, I mean, I know this video everybody has seen. There was a Trump who was reporting for a campaign rally. This is very popular video, and you can go through where a Trump's speech was being morphed. And you can see how the president's face is being overlapped with somebody else's face. And whatever the individual is saying,
if they don't want to love our country, if they don't want to fight for our country, they can. I'll never change on that. No.
When we see all these videos, when we see all these content, it sometimes, it's very scary because any content you posted on internet can be overlapped, can be morphed together with some other content.
What?
Even on Facebook, even this video had come up of Facebook where
total control of millions of people's stolen data, all their secrets, their lives, their futures. I owe it all to Spectre. Spectre showed me that whoever controls the data controls the future.
I wish I could tell you that we're going to be able to stop all interference, but that just wouldn't be realistic. There will always be bad actors in the world, and we can't prevent all governments from all interference. But even without our employees directly involved in the sales, we
imagine this for a second. Now, one man here in total control of millions of people's stolen data, all their secrets, their lives, their futures. I owe it all to Spectre. Spectre showed me that whoever controls the data controls the future.
Can you see the difference between the two videos? The audio of the two videos, the audio in the original video was very much different than the audio which was there in the manipulated video. So somebody can change the things which you say as well. So that's where these deepfakes are. I mean, for hilarious things, for emotional things, for sharing it, for funny things, it is a cool idea, but only for a specific cases where it helps us. These all are very popular content you would see where videos of usually president big people have been morphed, they have been manipulated, the audio is mixed, the facial expressions are changed, a lot of things have been done with the people who are usually popular. Their speeches are being misplaced. I mean, their speeches are changed. Everything has been, and even for a layman, it would be like it's a normal video, because a layman does not understand whether the content which is being shared is actually real or a fake. How are they generated? As I said, we would just understand, we'll just give you a gist of how these contents are being generated. This task obviously will require you to have a neural network, and you need to train the network for a minimum. I would say it will need a day or two for network to be trained on such videos. Even if you have to generate the content, you will have to train neural networks which are being trained for an approximately of 14 to 20 hours, and only then you would be able to replace the speeches, the audios, the facial expressions with somebody else's features. So if you have to train even for generating, you need time, you need patience, you need data, and you need a neural network architecture that will actually generate or will detect. So it is not an easy task. I'll also going forward, I'll also tell you how researchers are targeting this area, because this has become a very crucial thing for the researchers to identify. There are a lot of deepfake contents which are being circulated, and I'll also let you know what are the problems which we can face if these deepfake contents are readily available to us. Whatever the features the model learns, it can replace a face, even if it's a video, but it replaces the frames of the video. We'll come to that point one after the other. The algorithm which is learned, it for the audio content, what happens is the algorithm learns the input audio voices. So the audio voices and the mouth, you can see the lips, the lip and the audio syncing is also being done, and all this is done using neural networks, using GANs. GAN is the network, deep learning network, which is specifically used even for detection and even for generation. Both of these techniques can be easily done using GANs. And they have also tried to texturize your facial features. As I said, your expressions, your wrinkles, they try to blend, giving you a similar existing video. They try to blend. So first, they'll extract your lip, they'll sync the lip with an audio. When the lip is being synced, it will again put it back to the texture with all the wrinkles and everything, which will look very similar to your existing video. In the end, machines can match videos, they can match your face, they can match your mouth, they can match anything to somebody else's face, somebody else's audio, somebody else's features, and it might not be a reality. Every content which you see might not be a reality. It can be it can be a fake, or it can be real. I mean, the purposes which they are being used, I just give a gist of purposes. It is used for amusing purposes, hilarious purposes, entertainment purposes, where you just try to morph your image or a video on somebody else's video and then circulate it for entertainment. It is used for entertainment. It is used for various other purposes where it gives a new dimension to a positive application as well, for education, for literature, for cinema, for emotional content. For all of these, it has a positive side also, where they give it a new dimension. Your whole entire house can be structured, can be generated by just visual virtual conversations, virtual reality. Even if the content or thing is not available, but you can place it in a video showing it a very beautiful house. So there are good things also which is being used for a deepfake content. The education and literature, yes, for human interaction, it makes machine learning profound. For example, these days everything is online. So for online content, you can actually have a bot morph with an image with a teacher's image speaking up to students, counseling. Different things can be used. These are the good things where deepfake content can be used. It can be used in cinema, where the actors who have a body double role. So if you have a body double role for any actor, they can use the same technique for the same features. For an emotional value, if you have a loved ones and if you have a grandparents, you have to show them pictures, your videos. You just use filters and send them. You use filters on your video chat. So all of these are the positive sides of deepfake content. But there's one dangerous and a very illegal and a deceptive side where it is being used. And technology is always where it has its pros and cons. So the dangerous side, the illegal side, in the negative ways where a technology becomes more powerful. That's the first thing, where the celebrity videos for revenge, for anything, it is actually a current scenario where the things have happened in 2017 at the end. That's when the first deep fake content was being published by using GANs. They took a revenge on a celebrity. They morphed, they overlapped their bodies, the actors' faces, and they just published it on Reddit. Reddit is a platform where it's a discussion platform. So they took for revenge. They try to use it. If you find an estimate of deepfake content used for, so far it's only for non-consensual images. It is usually right now it's less of this. But imagine if someday it starts generating these contents also. It is very, very risky for anybody who is a social person, who's a public figure. They are always at a risk. And risk being because a common man will not understand the content which is being shared with them is actually a deepfake generated content. Even this can be used as a manipulated what we call it as a manipulated proofs in terms of legal things. If somebody manipulates a content, again I would say Scarlett Johansson, even her video or even her images were morphed, and she couldn't do anything. It did damage her reputation, but she couldn't do anything. Financial frauds can be done. For example, if there's an audio, these days not yet popularly in India, but out of India there are countries where your audio signals are being used for authentication. As we have fingers, our audios are also used for authentication. So if you manipulated audio on somebody else's video and that is being used for your financial scams, they can be used. Somebody is talking on phone, if you have to call somebody, your audio can be mixed with somebody else's audio, and financial scams, financial frauds can also be done using this. There are fake news, hoax, malicious information being shared, political tricks being used, especially on Facebook and Twitter. Usually when there are political events occurring in anywhere, in India, in outside India, wherever there are political events occurring, there are a lot of fake news, political tricks used deliberately, which have been created. And they just deceive people because people believe in what they see. And somebody today, even if you go to your parents and if you ask your parents see some video on WhatsApp or on Facebook, and they'll come and tell you that, oh no, this is the thing which has happened. You know that it is a fake, but the older generation or a younger generation who have no idea about this, they will be deceived. They will be the person who might not understand what actually is being shared. Okay, As I said, politicians, yes, they have been also targeted. The most targeted politician in deepfake content is Donald Trump, and then Adolf Hitler. He's not there yet, but these are the images which are being morphed on each other, on especially political personality. As I said, deepfake content is very, very risky for a public figure. If you are a public figure, if you're a social person, these contents, these technologies will somewhere or the other come up to the person's reputation. How political tricks, they can mislead voters if these deepfake contents circulate. Putting up an allegation on somebody is very easy. This would mislead the voters, and somebody has to prove. It will take ages for the other person to prove whatever they have seen is not correct. It's actually generated. The fineness of the technology is so much that with bare naked eye, anybody can say that this is real. So usually for politicians, they falsely they do it themselves, but they, just to gain mislead voters, they try to generate those contents and circulate. And these are not the politicians who do it, but these are the people, the public people, who would just put up some content and they would just say, this is the see what the other person is doing. So this is what tricks they apply. And stammering videos, they generate videos whenever a representative is speaking. For example, if somebody shares a video, they create a stammered video. Like how we speak, we stammer. So they can create stammering videos, slurring speeches, a lot of things which will actually come up to somebody's reputation, to somebody's image, to somebody's hard work what they have put in. And that is why, and also we will deceive people. The worst thing here is they will deceive a common man. A common man will be misleaded with these contents, and that is why it is very, very, very important for us to identify, to detect these deepfake contents, which can come anywhere, which can be on our WhatsApps, which can be on Facebook, which can be on Google, which can be anywhere on the internet, circulated, and which can also be given as a proofs for our security personnels, that this is the thing, I have a proof somebody is guilty. So we also have to identify those, whether this is actually being an actual scenario or a real fakely generated scenario. So that's what we said. We are a democratic country, and democracy works until people believe. If people believe, democracy works. Otherwise, democracy doesn't work. And a common man will always believe on what is being shown. So we can see the deepfakes can cause a lot of relevant problems. When we have a problem, we should always focus on a solution to that problem, right? The photographs are widely available online, okay, which we can use it as our training data. I have a thing today. I'm going to tell you about the training data also. You can use a lot of training data for deepfake content. You would require data set, and I'm again telling you, the methods which I will show you is not the only solution. The discussion which I'm telling you is not the only solution, but yes, deep learning is the only solution to generate detection of artificially deepfake contents, because it is being generated by deepfake neural networks, and you will be using deep learning methods to detect it. I'm just skipping this because it's not relevant for now. I'll just talk about these apps. There are certain apps, face swap app, fake app, certain apps which will generate a lot of fake contents. It also generates a lot of deep videos, manipulated videos, audios, and people share it across for fun. It uses your phone's camera. It uses face swap. It's face-to-face swap. It creates a lot of audio contents. A lot of things is being done. We download these apps. I just talk about, we download these apps and we try to use it. You are not supposed to use them in your solutions. These apps are third-party apps which actually take your data, and so we will not use the tools which are readily available for deepfake detection. whatever technology they are using, if you are able to build it on your own, it's okay, but you are not using any of these apps or any of these tools which are available in the market. So we'll talk about what can be done. The first thing which you can do is a legal or an ethical framework which needs to be designed. Legal countermeasures will have to be very, very strict for a malicious deepfake content prohibition. Every country has some act, and that's something I am also expecting very soon. We are also in a progress of having our data law, which according to me is the topmost. The GDPR is the first one, which uh, which has tough rules for the data, whatever data related thing, if we do it. And everybody's waiting for our data law to just come in. And those acts, those legal countermeasures, if they are very, very strict, there would be less of a attacks usually with data. You can go and that's why GDPR is used in European countries, and European countries data law is very, very strict. So the draft which has come up for us is also is stricter than that, and we are glad. So the legal countermeasures are one thing which can be done, but that's not in our hand. What is there in our hand is to create a detection software. There are multiple researchers working on creating a deepfake detectors. Zerofox, Facebook, Google, everybody is working on this to create a software which will detect this deepfake content. To be honest, there was a competition also on this by Facebook, and the highest scorer for that competition was 0.48, 48%. So only 48% of the deepfake content was recognized correctly. So it's still in the research area, and that's where we have to build ourselves. We have to come up with a solution which has a higher accuracy, higher precision to detect these contents. I told you about these large companies. They have come up with an initiative, like how we have come up with an initiative. Everybody, you will find millions of data sets available, large database available with Facebook and Microsoft for your videos, for your audios, for your images, and for news content also. So there are a lot of deepfake detection challenges where and it's still there. So like we have a hackathon here, the challenge is every researcher is going through, and every researcher is facing this. So they have a policy violation act, and a lot of these models are already implemented. Go through these models, check how they have been the models have been generated, and come up with a solution, a better solution which will integrate all. Currently you have something for image, you have something for video, you have something for audio, you have something for news. Try up with a solution, come up with a solution which will itself can be applied anywhere. And what kind of solutions can you come up with? I'll just tell you. You can create a filter, like a spam filter. You can create a filter, a software filter, which will just reject the malicious deepfake content being uploaded anywhere on the internet. If this filter has been used like a spam filter, it will just flag the content, and the content will not be uploaded. So these filters can be used on websites, on Facebook, on social media platforms, anywhere. So like a spam filter, you can come up with a filter which will automatically block the content. You can come up with a plugin. Plugin is something you create a software, create a plugin, which will again flag it, but you can come up with a plugin which will automatically, if a user is surfing on, plugin is something, which while uploading it is not useful. It is useful when a user is browsing. So you would have seen Twitter has started flagging things like this content is this news is not real, it's a fake news. Twitter has started marking it. So you just flag the content, whichever content. If you're surfing on the web, just flag it that it is a fake content, potentially fake content. Do not believe this. And when there's a flag, okay, a person who is viewing or surfing or browsing is somewhere that okay, it is potentially a fake, I should not believe it. And you can come up with another solutions where you're registering the user for authenticity and check it. So it's an authenticity check before uploading. So some kind of solutions where, but you have to build a software at the back end. These are the front end which you can come up with registration of a user for authenticity, declaring their authentic content, and can check in the background whether the video posted is real or image. I'm talking about video because video would be difficult for everybody to understand, but we so that's why video, and video posted online is a real or a not. So on a whole, the researchers are very optimistic. As I said, everybody has a very critical eye on this thing, detecting deepfake content. They are very skeptical about text and images which are shared across, and it's not a recent problem. It's since the day Photoshop existed in the market. Today, deep learning methods are used, and previously, before deep learning methods, people used to Photoshop. We always used to say that the image is Photoshop. Photoshop means some manipulation is being done on your image. In a similar content, those manipulations are now done by machines. And that is why they're very finely and accurately, and nobody can understand whether it's a Photoshopped image or not. So we have to be careful into our application. We have to generate a positive applications, relevant applications, which will eliminate the potential risk of these content. Now we come up to a model which is a suggested potential solution to detect. It can be used for videos also, and it can be used for image also, because video is ultimately frames of images. You're watching video. Video is what if you click thousands of pictures in a second and then keep playing it one after the other, then it's actually image, a click of an image. 1,000 images in a second, depends upon resolution of the camera. So 1,000 images in a second, and you play it one after the other. So actually a video is collection of a lot of images together. So image detection technique can simply be replicated for a video. The only step which will be extra would be converting your video to frames. Okay. Extract images from the video, convert it into frames, and on each frame you will have to apply this technique. Apply deepfake image detection technique, and then collaboratively at the end you can calculate average of all whatever the model has given you the result. At the end you can just average it out. This time I'm also letting you know about the softwares which can be used potentially for generating this deepfake content. And I prefer going with open source. You can use whichever software, whichever operating system you have. Linux is good for training neural networks. So you can have a Linux as an operating system. You can use Python 3.5 as a programming language. The libraries potentially which can be used with Python is OpenCV, because we are working with image, we are working with video and audio. All of them together can be worked with OpenCV. TensorFlow, Keras, or PyTorch. These are the three frameworks which you can use for training neural network model. And NumPy, Pandas, whichever other libraries which you require. The best part with these software library is once your model is trained, you do not require these libraries. It's only required till the training of the model. And once the model is trained, you don't require these libraries. So when you would create a plugin, or you would create a software, you would create some things, then you won't require these libraries. You would just require the model which is being trained. I just come with an overview of how the things will flow. The first thing would be for you to get the data. There are a lot of data available online which you can search, which is face forensic F2F data, which is actually face to forensic data. There is also a data set available by Facebook, available by Google, available by Microsoft. These three big giants also have data set on their platform. Forensic to face, you search F2F or forensic to face, even that data set is also available, which is actually an ICPR conferences data set. So you can also use that, and they all are open source data sets. So get the data, select the data. As I said, it's the video data. You have to extract images from the videos and save the images. You'll have to do pre-processing whenever you are working with images, any kind of data. Pre-processing is a very crucial step which you have to always do. So you have to do a pre-processing where you will have to detect faces. Since we are looking into human detection, human fake content detection, so we will also have to detect the face. The facial region we'll have to detect. We'll have to detect the boundaries, the landmarks. We'll have to align, crop, how much portion we want. See, if you were watching my video, I'm at the center and I have a background. For processing, for giving it a neural network, I do not need this background because I'm only interested in myself. I'm only interested in the person who is talking, a person who is there at the center of attraction. I'm only interested in that. So I only want this, so I will crop. Whatever frames of images I will get, I will crop. I'll align, I'll crop, I'll resize and then save it. Why are we doing pre-processing is because that we are just reducing the features, the data set, we're reducing it. And after pre-processing, we actually come up with a process. The process is, first is you will train the models. There are two models I would talk about, InceptionNet and MesoNet. These are the two architectures which you can see to detect the deepfake content. MesoNet is basically a model which is more into classifying a gender. As I said, the a woman's image is overlapped with a men's image, or a girl's image is overlapped with a boy's image, vice versa, men's image is overlapped with a girl's image. So all these gender classification is also somewhere a part which you will have to see. So MesoNet is more likely to identify gender with your image. InceptionNet is more likely to learn the features and give you the results. Both of these models, when you will process, they will classify the gender first, and then they will classify whether the content is a deep fake or not. Why gender classification is important? Because as I said, the only gender thing can also be changed. So gender classification will give you an added feature to your detection technique. So I'll just show you our deep detection flow. You take an input image, you detect the face, you crop, align, then create a landmarks. Landmarks is the face for facial landmarks. We have facial landmarks, 5 facial landmarks. There are plenty, but 5 are crucial to identify a person. 1 is here, 2 is this eyes, nose, and this region. If these 5 landmarks, you can identify an individual as a person. Similar techniques is used in machines also to identify the landmarks, and with the landmarks you crop, align the face, resize the image. The pre-processing is done. Once pre-processing is done, as I said, you will pass it to a MesoNet model. So MesoNet, you will have to train. You will have to train MesoNet. There's an architecture of a MesoNet available. You will have to train MesoNet network. You will extract features. After feature extraction, you will have to train, and which will classify the gender. With this gender classification, you will now be training on the InceptionNet network, which will give you another classification, whether it's a deepfake or not a deepfake. After your model is trained, you will go for evaluation step. Where evaluation, the 3 important things you will measure. First is cost. What is the loss cost of the model? What is the accuracy? How much is the accuracy, and how much is the F1 score? F1 score is basically it's a relative score between how much true content is being, real content is being recognized, and how much fake content is being recognized. So it's a relative score between the two. So F1 score, these are 3 evaluation matrix which you can follow. Accuracy should be high, cost should be very, very low, and F1 score should be very, very high. So accuracy high, cost should be very, very low, and F1 score should also be very high. When you're extracting an image, how can you extract an image from a video? As I said, image detection can also be used for a video detection. Read the video. After reading the video, every video you will have to save on frames. If the frame is extracted from a video, keep saving it as a image. So one by one video after the video, one frame after the frame is being generated, extracted, and saved as an image. So every video you will create a folder and save the images inside the folder. As I said, you will have to also do the testing. Once you, I'll show you a demo of this also. So you will have to also do testing. You will have to test the overall model whichever you have generated. So you will have to test image extraction, whether the extracted images are correct, all the facial landmarks are correctly classified or not. Second thing you will test would be your gender classification, whether your gender classification model is correctly working or not. You will test image pre-processing. The pre-processing part is correctly done or not. You will also test the retained deepfake detection model, the entire model, and this process is called unit testing. Then you will do integration testing, because you will combine all of them together, and then you will test from start to the end whether everything is working fine or not. And then you will generate a software, as I said, whether you will generate a plugin, you generate a web filter, something you will be generating at the end, and you will have to test that thing also. You will have to evaluate at the end. And as I said, for evaluation, we will only look into accuracy. Accuracy is how much of a positive or how much of a correct, whether it's positive or a negative, divided by the total. So we generate accuracy, and precision is how many true positives are there, and recall is how much of a true positives are there. So since we are dealing with a fake content, we have to identify the false ones correct. When you have to identify the false one correct, we will go with the F1 score. As I said in the previous slide, F1 score is something which we will be looking for. The higher the value of your F1 score is, the better the model for detecting the deepfake content is. Before I just show you a very small demo of the models, which is I won't be training the model, because it is, I told you, for a deepfake content detection you have to train the model for at least 40 to 18 hours to come up for the model to give you good results. So I already have a pre-trained model with me, so I'm going to use the model and show you how can you use for detection. Training part I'm not showing you, I'm just showing you the detection part, the later part. The training part is very similar to how other neural networks are being trained, but it takes a lot of time for training. So that's the reason I will not show you the training part. I'll just share my screen. Sharing my screen for the demo of the code. Just trying to connect to my collapse system and will share my screen, switch my tab. Is my code screen visible? Is my code screen visible? Okay. So you will have to have a lot of libraries while training the model. And since we are not training right now, we are just extracting the features and everything because I'll be using the image from the scratch. So we'll be extracting the features. The frameworks which I'm using is PyTorch, and I use Torch framework because it's faster than the rest, and it's more like an OOPS concept. Somebody who is very familiar with OOPS can go with this framework. You have to import all the libraries. Once you import the libraries, there are different architectures, as I said: ExceptionNet, MesoNet, InceptionNet, different kind of architectures which you can use. There are different data sets available. What the data set I have used is ICPR's data set and also F2F phase 2 forensic data set. These two data sets I have used to train the model on, and I have taken samples of these data sets, a real and a fake sample, to show you, to demonstrate a demo to you. So we'll be using EfficientNet Auto ATT-V4, which is again an inception network architecture. And if you have to look into this architecture, you can check out the architecture on TensorFlow's page, directly page. You search it on Google, type in InceptionNet, exception model, any model architecture you want, and we will list down how many networks are there, what architecture is being used, everything would be listed there. Since we are doing deep network, we'll always see whether we have CUDA installed or not. So CUDA should be installed in your device. We'll train the architecture, we'll load the image, we'll transform, we'll create a facial expression, detect the face, read the video, extract faces, save the faces, and once the faces are being saved, we will go forward. Before we look into the content, I'll show you two videos which I'll be looking into. Okay, so we have face extractor, we have video reader, we have architectures, different architectures, which have already pre-trained architectures. I'm not showing you the training, I'm only showing you the detection. As I said, since we are using deep learning, we need to have a GPU with us. And as I said, face size I have put as 224, frames per video I have put 32. Usually resolution of a normal camera, of a web camera, is 32 frames per second. So a web camera captures 32 frames in a second. So that's why our frames per video is 32. I am getting the weights of a model. Once the weights of a model are being downloaded, and I will read those weights because I have saved the model in a public platform where I can download the models, and the model is being downloaded. It's my pre-trained model, so not an issue with that. You can train your own model and use it. So it's downloading the model from the backend. Once the model is downloaded, you can use the keys, the trained model, because I'm doing training equals to false. With the same model, if I'm doing training equal to false, that means I'm using the model for testing. The weights, the model gets stored here: blaze face ankles.numpy.pth. These are the formats where my model is already saved, and I'm using the same models. Now I'll show you two of the videos. One which is a real. The first video which I'm showing you is a real video. Okay, we will be using it for the same video which I'm showing you to now. It will appear it on the screen. It's a real video. Yeah. So on the screen which you can see is actually a real video. It's a sample video of 10 seconds. And I'm telling you beforehand that it's a real video. Okay. And I'm going to show you the fake video. Ten-second video. This is a fake video, and the one which I showed you previously was a real video. Now both of the videos I'm doing for processing. For processing, for detection, I'm using both the videos, okay, fake and a real one. So the first video, as I said, was a real video. The second video is a fake video. I'm going to extract the faces from the video. So I've extracted faces from a video file and stored it in this variable. I have extracted faces from a fake video and stored it in this variable. And now I'm picking up first frame, just one frame from each, and I will try to show it to you. So this was actually a video you saw, and I have just removed of one frame. This is one frame, this is another frame. So just a frame of a video, and just predicted an image detection on it, the model which I have trained. And you can see that on the left one it is saying as real, and the right one it is saying as a fake, right? So with just one frame, the model is able to identify whether the video content is real or fake. As I said, we will have to do it for all the frames, not just one frame, all the frames. So we will loop over the model and keep predicting frame on frame for every video. So every frame we will have, and we will pick up the best confidence score, whichever is available. And I'm going to plot it. And you can see with the real videos, your score is very, very low. It's 0. The score is 0. The FN score, as I said. And for the fake one, it is very, very high. So it is for all the frames. There are 300 frames. 32 frames in a second. We have a 10-second video, so we have 320 frames, and we are predicting for 320 frames. And every frame for a fake video, you can see the model for almost all the frames, the model has said that it is a fake, and for the real, for all the frames, the model has said that it is a real image. And we will just do an average at the end. As I said, we can do an average, and it gives you an average score that a real video is 0.05, that is 0.005, that is my 0. The value is given by the model is 0, and for a fake it is given as 0.9. It's a binary 2-class problem. So real video, 0 score, that means it's a real video, it's not fake. And a fake video, its value is given as 0.09, which is 1. It's ultimately saying that it's a fake face or a fake video. For video, we will do it frame on frame for each of the frames in a video. And for a image, we can use the same model for image. We'll just pass on one image. For image and video, I have given you one solution. The only thing which I have not catered to this is an audio. You can also cater to this audio by passing audio frames, but that will be very tricky. You will have to modify the architecture so that audio also gets attached to this, or you can create a separate model for an audio. It all depends. If you can modify the existing architecture, then you can fix in the audio in the same model, or you can generate another model where you can use audio, because audio will also require you time temporal features. So for audio, you can create another model and then combine at the end together. Whatever content, if else condition, you can use to combine all the models together. Okay, so that was a short demo for detection of a fake video or an image. As I said, there will be some system limitations. The dataset will have some limitations. We will have to do some assumptions, which you will have to state what assumptions you are doing. And there will be some algorithm, some scope of an algorithm, some assumptions which you will have to list it down. As one model will not be suffice for all the faces, for all the races, for all the genders, for everything. One model will not be suffice. You will have to create certain models, certain ensemble models. You would have seen I had used 2 models, Mesonet and InceptionNet, for the same purpose. You can use different models. There are a lot of models architectures available. You can create your own convolution neural network architectures to detect this, and you will have to create a very deep network to detect a deepfake content. There are a lot of data sets which are available, and the model which I have trained might not be working on some other things, because I have used some assumptions to it. So you will also have to list down your assumptions and what can be done for your model if these assumptions are not fulfilled. What are the chances? What is the failure of the system? Everything you will have to list it down. Scope of the model you have to list it down. System limitations you will have to list it down whenever you build up an algorithm and come up with a solution. That's it. And I have listed down from what sources I have taken this, and I've taken video from these sources. So I have listed it down and given a credit to them. And that's it for today. Just understand that more deep your network is, the more problem statement you understand, the better solutions you will get, and the better ideas will come up. For deepfake, I would recommend you to actually go and see Facebook's website, and they also have a lot of ideas which they are implementing, and there are a lot of research papers available, so you can read those research papers, and it is your time now to convert those research ideas which are stick only to the papers. paper submission to convert it into reality. So pick up that great research paper, whichever you would find, and try to create a modified or architecture from that research paper. Try to build up something which can be used into reality, because this is the time where we have to convert our research work into production, and where you understanding the problem statement, I always say, is very, very, very important. That's it from my side. If you have any questions, you can ask. I'll be happy to answer those questions whenever possible. And let me know if there are any other things in the previous one also and in this one also. Over to you, sir. Submit.
Yes, ma'am.
तो ये करना है क्या, लॉग ऑफ करना है?
I guess मैंने सर को इन्फॉर्म कर दिया. The session has been done. Let's see what it is.
ठीक है ना?
Hello?
Yes.
हाँ, सर ने बोला कि सेशन एंड कर देने. Like he will post it.
ठीक है.
Okay.
Okay.
Alright. Thank you.
Bye.
Bye bye.